Welcome back everyone to part 2 of our discussion on statistical estimation within categories. Let's head over to the notebook and code out what we talked about in the previous lecture. Alright, here we are at the Jupyter notebook. I've gone ahead and imported NumPy, Pandas, Matplotlib, and Seaborn, and then we read in the data dm_office_sales.csv located in the Seaborn folder. So here we can see that we have some categorical variables such as the division the employee works in, the level of education that employee has, and we can also see that there are salary and sales data. Let's go ahead and just do a count of the divisions and level of educations. We already know that I could just grab one of these columns such as division and then ask for value counts and get the counts themselves. But alternatively, I could visualize this with Seaborn. So the way that works is by creating the count plot that we discussed. So for the count plot, I simply say the source of my data, df, and then what I want on the x-axis. So for that case, it'd be division. And you'll notice, by default, the sizing looks a little weird. Looks like there's some crossover here. So we already know that with Seaborn, because it's built on top of Matplotlib, right before this, I could actually grab that figure object and set it to some particular figure size in order to stretch this out accordingly. So I could say 10 by 4, for example, and then we stretch this out. And you'll notice that if it ever looks a little blurry, you can always edit your DPI just to make it a little sharper. All right, so this is essentially the same data that we just had up here with the value counts, but now it's shown visually. So I can really easily see that it looks like printers, peripherals, and office supplies division have about the same number of employees. Keep in mind that the Y scale here is starting all the way at 0. You should always be careful when showing these count plots to not try to deceive somebody by having your Y limit start at another level that is not 0. For example, I could have said PLT YLim here and try to start it right at the beginning of something like computer software. So if I said go ahead and start at 90 and then go to, let's go ahead and say 260, notice what happens. Just briefly looking at this plot, you might think, oh, you have almost no employees in computer software. However, it's a little deceiving because of where the y-axis starts. So you just want to be careful of displaying the information correctly and in a truthful manner. It's really easy to deceive and kind of almost lie with plot types like this. You could also try to do the opposite and just make the y-axis huge, like all the way to 1,000, and then here everything looks much more similar. But again, you should just let Seaborn choose the axes, and more or less it'll show a more honest depiction. Okay, so if we ever wanted to change the x, I could have also said something like level of education. Whoops, make sure we spelled this right. Level of education. Run that, and I can see the level of education, and here we can see master's degree. There's hardly any people with master's degrees, and if we want the actual numbers, what we could always do is say df level of education, and then just say value counts. And here we can see there's actually only 3 people with a master's degree, so that's why that line is barely visible. Keep in mind that we didn't have to actually specify what goes in the y-axis because this is specifically a count plot, so it's always going to be based off the count. The other thing to keep in mind is we could add a hue parameter to split these up into further categories. For example, maybe I could say level of education and then say hue is going to be based off the division that people work in. So now I can see, based off someone's level of education, what sort of divisions are they more likely to be working with. Alright, so the last thing I want to show you here for count plot is that you can always vary the actual color mapping you use based off the Matplotlib color maps that we discussed before. So recall that if you just Google search Matplotlib color map or use the actual link that we provide for you, there's a Matplotlib color map reference, and you scroll down and you can see all the color mapping codes. Now in general, if you're doing something like a count plot or any categorical plot, you should scroll down and do a qualitative color mapping because you don't want something continuous for these sort of plots, even though they kind of look nice. You should probably just choose something that has different colorings that are distinct from each other per category. So let's go ahead and use set2, for example. We'll come back here, and the way we do this is we say palette is equal to set2, and now you're able to color this differently. So you can go to those color mappings and play around with them. Now we also mentioned in the previous lecture that count plot is basically a special case of a general bar plot. So count plot is a special case because the y is always going to be just the count. How many rows do you have per category or per subcategory of a category, as we've seen here. So bar plot allows you to use any sort of metric for the y-axis, and it could be any sort of function too. So what we can do here is the following. I'm going to say sns.barplot, and then here I'm going to say my data is equal to df just as before. Let's choose level of education as the category again. And then what I can do is set y equal to a continuous column, such as the salary. However, what I have to decide is what am I actually going to show as the aggregation method per group. So I do have to decide somehow, based off level of education, I'm going to aggregate these almost as if I was doing a group by. So after calling my group by, should I show the mean salary? Should I show the total numbers of salaries, the counts, etc.? So the way this works is you have a third parameter called estimator, and this is where you pass in the NumPy function that you essentially want to call. And it should match up with the other functions that we talked about. So one of the most common ones is np.mean, which essentially says, after grouping them by level of education, go ahead and calculate the mean for the y column per category. So calculate the mean salary per level of education. And then the other thing to note is there is a CI parameter, and if you expand on this, you'll notice that there are default estimators and a default CI value. The estimator by default is actually mean, so if you want, you can swap it out or just leave it blank. And the other one is CI, which is the confidence interval. So if we expand on this and eventually see the CI parameter, it's the size of the confidence intervals to draw around estimated values. However, if you want, you can also say SD, which would essentially draw the standard deviation as that black line. So if we say SD, which in my opinion makes a little more sense, you now get to see the standard deviation and the mean for that salary visually. And as always, we can expand on this just to make it a little clearer. So I can always grab plt.figure, come down here, paste it right above, and here we can now see the average salaries as well as the standard deviations. And keep in mind our discussion from the previous lecture where it may or may not make sense to show this visually instead of with a table. Clearly I can see here that there is little standard deviation on the average salary you're going to make if you have a master's degree at this company. However, what's not super clear just from this plot is how many people actually have a master's degree. If I scroll up here, I would eventually find out that it's actually very little. And we can see here from the count that it was just those 3 people had a master's degree. That is definitely not clear or even shown in this sort of bar plot type. So keep that in mind. You always want to do your best to kind of show the information or just show a table of the information. And lastly, with this one that I want to show you here, is there hue parameter just as before, you can add it in as well. So then you could show the average salary per level of education per division. So now we're showing a bunch of information here. The thing to keep in mind is you'll notice master's degree doesn't have a black bar on these because essentially 1 point per master's degree. These are the only 3 employees with master's degrees, so that's why there's no standard deviation. It's essentially 0 because there was only 1 point represented here. And the other thing that may annoy you is the legend, the automatic placement, is not ideal. It's covering a lot of the plot. So what we can always do is use what we already know about legend placement and say plt legend and say bbox to anchor that we're already familiar with. Make sure we spell this right. Anchor. And then set it outside the plot just as we've done before. So I can say 1.05 and then maybe go ahead and say comma 1, run that, and it will go ahead and set it outside of the plot. All right, so using all the skills we learned before with Matplotlib, I can easily apply those to a seaborn figure because it's built directly off of Matplotlib. That's it for this lecture. Thanks, and I'll see you at the next one.